Hi guys, I hope you're doing well and that you're still all healthy. At this point, it's been a few weeks, so hopefully everybody is still okay. We are going to move on and go to section 5.2 today. We're going to do 5.2a today, and then we'll finish 5.2b on Wednesday. So the warm-up is just obviously what we were doing before, but I just want to make sure we all understand that the one on the left is the normal distribution and the one on the right is not a normal distribution, even more so than the fact that it's even. A lot of you guys understood that on your homework. I saw that you would have told me that this one was not, because it's kind of pushed off to the left in this case, and then this one on the right is more centered, and then your inflection points would give you where your standard deviation is, and so on and so forth. But on your homework, just to clarify, there was one that looked really pretty, but it came down below the x-axis, and some of you told me that was okay because it was even and it was symmetrical, but the fact that it came drop below the x-axis means it's not a normal distribution. So just make sure you understand that it can't touch the x-axis. It's like your x-axis is an asymptote in this case, and so it can't cross, and if it does, then it's not a normal distribution. All right, today we're going to start talking about z-scores. So we kind of have to understand what the rest of our stuff means to help us remember or figure out what a z-score is going to be. X is always going to be your data point. Okay, so you collect data and every number that you get is an x value. Okay, mu we know is our mean. Okay, so the average of all of our x's put together is going to be our mean. And then baby sigma is your standard deviation. A lot of you guys probably don't even remember what that means. Like, you just know it is standard deviation. Standard deviation, remember, tells us about how spread out our data is. So the bigger your standard deviation, the bigger your range is generally, or just your data points are very far apart from one another. If your standard deviation is smaller, that means that everything is a little bit closer together. It tells you on average how far away something is from the mean. Okay, so if your standard deviation is 5, that means that on average a data point is 5 points away from your mean. Okay, so what we're going to do today is we're going to take it one step further, and we're going to come up with a z-score for your data points. So each individual x value can have a z-score. And what the z-score tells you is it tells you how many standard deviations you are away from the mean. Okay, so we're going one level deeper. Instead of just in general, this is how far away it is. It's on, for this specific data point, this is how far away you are from the mean. So the z-score is the number of standard deviations x falls from the mean. The way you find it is very simple. You take your x minus mu and divide it by baby sigma. Okay, so x is your data point, mu is your mean, and baby sigma is your standard deviation. And when you do that, you get your z-score. Okay, these numbers shouldn't be that big, because you shouldn't be multiple. You shouldn't be 5 standard deviations away from your mean. That's very, very, very far away. So they should really be 4 or less for the most part. So these numbers are going to be pretty small. All right, so this says that the mean speed of vehicles on the highway is 56 with a standard deviation of 4. So just like if we were in class, as you're going through, you can label it. So the mean is going to be your mu, so 56 is our mu. Standard deviation is 4, so that's your baby sigma. You measure the speed of 3 cars, so that's your data. So each of these numbers are your x's. So 62 is an x, 47 is an x, and 56 is an x. And find the scores that correspond to each speed. So we're going to do this 3 times, and I already wrote this one out, which probably isn't overly helpful for you, but I'll write the first one out again, just start from scratch. So if we say I need to find the z-score, sorry, I'm in a new program, I don't know how to use this one. Okay, if I need to find a z-score for my x value of 62, you're going to take your x minus mu divided by baby sigma. Okay, that's your formula. X minus mu divided by baby sigma. That's for all of these. Okay. So my x value is 62. So that's where this comes from. Minus the mean of 56 divided by 4, because 4 was my baby sigma. Okay, so all of these, the 56 and the 4 get reused every time. If you look ahead, 56 and 4 on every single one of these. What changes is your x's depending on what you're plugging in. Now, be careful with your calculators because you have to do the top, hit enter, and then do the bottom. So you're going to do 62 minus 56, hit enter, divided by 4, and we get 1.5. Okay, so the z-score for 62 is 1.5. That means that the person that was going 62 miles an hour is 1.5 standard deviations away from the mean. And we're going to get to above and below the mean in a second. So 47, so the person that was going 47 miles an hour, you're going to do 47 minus 56, hit enter, divide by 4, and we get negative 2.25. 56 minus 56 is 0. 0 divided by 4, or what 0 divided by anything is 0. So let's look at these three as a whole. Again, just the x values changed. The 56 and the 4 stayed the same because your mean and your standard deviation for a specific set of data isn't going to change. Okay. Now, your first z-score, if you notice, is a positive number. Your second z-score is a negative number, and your last one is 0. So there are different ways that you can do this, and you're going to get different types of numbers depending on what kind of x value you were given. Your basic math skills should tell you that the first one is positive because of the fact that 62 was bigger than 56. Okay? So think about what those numbers represented. 62 was your data point, and 56 was the mean. So the fact that they were going faster than the mean, okay, so they were above average speed, means that your z-score came out positive because you were above average, okay? So not only were they 1.5 standard deviations away from the mean, they were 1.5 standard deviations above the mean. Okay, so this is above because it's positive. Now the second one, you had a negative value because 47 was smaller than 56 because they were going below average. So they were 2.25 standard deviations below because it was a negative value. So you should be able to look at a z-score and know if they were above average or below average, and then how many standard deviations away they were. The third one was 0 because 56 minus 56 was 0 because they were average. So if your z-score ends up being 0, that means that x was equal to the mean. They were going average, okay? Or they were average. Okay? So when your z-score is positive, you're above average. If your z-score is negative, you're below average. And if your z-score is 0, you are average. You are going, or you are, whatever that data point is the same as the mean, okay? I'm not going to go through these examples, but you have access to the blank notes that I would have normally given you in class. You're not turning them in for points, but if you want to follow along and you want to try to do these on your own, you can do that if you want. All right, I guess I can give you the answers to this if you want to do them. Okay. We can also go from, if we know the z-score and we don't know the x value, you can go backwards. So I'll manipulate the top equation for you to show you where the bottom one comes from. If I wanted to solve for x in this equation, just like basic algebra, you're going to get rid of the bottom first. So you're going to multiply both sides by baby sigma to clear this fraction. So that gives you z times baby sigma equals x minus mu. Again, we're trying to get x by itself, so then you'd add the mu over. So that's z baby sigma plus mu equals x, which is the same thing that is down here, just in a little bit of a different order. okay? So the point here is that if you know the z-score and you're trying to find the x value, you can use this manipulation of the same formula to go in a different direction, okay? So mu plus z times baby sigma. So it says the speeds of the vehicles along a stretch of highway have a mean of 56, so that's the same. Oops. So 56 is your mu. And a standard deviation of 4, so that's baby sigma. Find the x, find the speeds, the x corresponding to the z-score. So these are your z's, 1.96, negative 2.33, and 0. First of all, let's note that we've got 3 different kinds of values. This one's positive, which means that x value should be above the mean, so this answer should end up being bigger than 56. Negative 2.23, negative z-score means you're below the mean, so that answer needs to end up being below 56. 0, we shouldn't even have to calculate that, because if your z-score is 0, then you are average, so x is 56 in that case. I'll do the work for you anyway, just to show you, but we should understand that when your z-score is 0, your x value is equal to your mean, okay? All right, so for the first one, we are using this formula from up above because they gave us the z-score, okay? So we're going to do x equals mu plus z times baby sigma. So x equals mu plus z times baby sigma. So our mu is 56 plus z in the first case, the first z that they gave us was 1.96. I guess I don't need to put that in parentheses. And then baby sigma was 4. Okay, the 2 numbers in blue are not going to change when I come down here. Those are going to stay the same. If we have to calculate this one, it's going to stay the same for this as well. It's going to be the x or the z value in this case that's changing. So down here, my second z value was a negative 2.33. Here my z value was 0. We could get our answers from here, okay? So since we don't have any fractions, we can put it in our calculators all at once. So you can just do 56 plus 1.96 parentheses 4, so 63.84. Now, that's your x value, which means in this case that was their speed, which you should have known that that needed to be bigger than 56. So 63 is bigger than 56, so that seems right. You can't see my negative sign very well right here, but this is a negative 2.33. So 56 plus negative 2.33 times 4 is 46.68, which is below average, which you knew because your z-score was negative. When your z-score is negative, your x value has to be below the mean. 56 plus 0 times 4, 0 times 4 is 0, so that's just 56, because if your z-score is 0, then your x value is equal to your mean, okay? So those are the 2 formulas. These 2 formulas are the ones you're going to be using depending on if you're given the x value or if you're given the z value, okay? If you're given x, you use the top one because you're trying to find a z. If you're given z, you use the bottom one because you're trying to find x. Again, you can do these if you want. Those are your answers if you want to check, okay? All right, this last part is more so going to lead into next week's lesson, or I guess Wednesday's lesson, but I just want to kind of give you a heads up where we're going. This is a standard normal distribution, so not just a normal distribution, but standard normal distribution. When it's a standard normal distribution, your mean is 0, so that's in the center, and your standard deviation is 1. Okay, so your inflection points are each 1 away from the mean. And what we're going to use this for in the future is we're going to actually talk about the area underneath the curve. Okay, so under here has an area of 1. And all of the numbers you're going to be looking at are going to give you the areas to the left of the curve. When you get down to about 3.5 in the negatives, there's pretty much nothing to the left of that. 3.5, negative 3.5 is about the bottom. Likewise, since it's symmetrical, positive 3.5 is the top, so all of your data is to the left of this. Okay, and we'll talk about this, but just keep in mind when we're going to do standard normal distribution, your mean is in the center of 0, and your positive or your maximum and your minimum is about 3.5 and negative 3.5, which is what all of these say. Okay, the cumulative area is 0 for negative 3.49 because there isn't anything to the left of that. The area gets bigger as your z-score increases because you're moving further to the right and leaving more area to your left. When you're at 0, that's in the middle, so your area is 50%. Half of your stuff is below that. Okay, so this is 50% because you're already at 0 in the middle. So then when you're at 3.5 about, your area is 1. Okay, so we'll talk about that more later, but that's just kind of an introduction to what we're going to be doing. Today, you need to be focusing on finding your z-score, finding your x value using these two formulas. So this formula, if you're looking for your z-score, which means they gave you the x. This formula, if you're looking for your x, meaning they gave you your z-score. For your assignment, you are doing your 5-2A worksheet, numbers 4 through 9. Be careful, 5 through 8 have parts A and part B. I only want you to do part A for 5 through 8, okay? If you have any questions, please Zoom me or send me a message, and I will be happy to help you. Miss you guys. Hope you're doing well. Bye.